Section 2 of the prerequisite chapter is on linear models and rates of change. Now, linear equations have been around since middle school. We were determining slopes of lines and x and y intercepts and creating t-charts and graphing lines. We should be able to do this without any review at all. But we're going to review just a little bit, including slope, because slope of a line, a non-vertical line, is also considered a rate of change, and we're going to use the idea of slope when we talk about different kinds of applications. The slope of a non-vertical line is the measure of the number of units that the line rises or falls vertically for each unit of horizontal change from left to right. So if you're given two ordered pairs, x sub 1, y sub 1, and x sub 2, y sub 2, notice the band-aids there, people, so you won't be so grossed out by my hands, where x sub 1 is not equal to x sub 2 because it's not a vertical line. The slope of the line that passes through the points, delta y over delta x, we use the letter m, lowercase letter m. It comes from a French word, monter, which means to climb, like to climb the slope. And since Descartes was French, it kind of makes sense. And it's the difference in the y values over the difference in the x values. That's what delta means. Delta means the change in the y's over the change in the x's. Now notice here, the subscripts indicate that you have to subtract them in the same order. So from the ordered pairs, now you could have y sub 1 minus y sub 2 over x sub 1 minus x sub 2. It would give you the same value for slope, just have to be consistent with it. So both subtracted coordinates come from the same point. That's the only way you could really get messed up, or you make a silly mistake with arithmetic. Now, slopes, we have positive slope, we have negative slope. Positive slope would mean that the numerator and the denominator are both the same sign. So you're either going up and to the right or you're going down and to the left, but positive slope of a line would be something along like this. And the negative slope means that either the numerator is negative when the positive denominator is positive, or vice versa. So it would be going down and to the right or up and to the left. Zero slope means that the numerator is zero. That means the y values are the same, which means that you have a horizontal line. So if we have zero slope, we're looking at a horizontal line. Now, notice it said non-vertical because you can't have zero in the denominator, and if the x values are the same, you have a vertical line. So we refer to vertical lines having slope, or having slope that's called undefined slope, or sometimes they even say no slope, although no slope makes people think zero. No slope or undefined slope are the same thing there. Now, I'm going to plot points, and I'm going to graph the points, and then I'm going to look at my rise and my run here, because we know delta y is rise over run, vertical change over horizontal change. So if I, for part A here, if I was to graph the ordered pairs, 3, 1, 2, 3, negative 4, 1, 2, 3, 4, they'd be about here, and 5, 2, 1, 2, 3, 4, 5, up 2. This line appears to have positive slopes, so let me get my straight edge out. I just happen to have my handy dandy straight edge, and I'll line them up here, and best that I can, I'll draw my line. The slope of this line is clearly positive, and I can find the actual slope, the rise over run, by counting 1, 2, 3, 4, 5, 6 up, and then 1, 2 to the right. So up is positive, right is positive, down is negative, left is negative. So my slope here would have a vertical change of positive 6 over a horizontal change of positive 2, which of course is 3. Now, I know that we could just plug right into the formula, but I wanted to show you from the graph itself that you can find this as well. Now let's consider example B here. So I'm just going to, here, let me get a different color pen, so maybe that would help a little bit as well. Okay, so let's go with 2, 1 right here, and 2, 5, to the right, up 5, 2, 3, 4, 5. Well, you can see from this that this is vertical, and I'm going to try to draw it neatly here if I can. And I have a vertical line here, which means, of course, that the slope is undefined. Now, I could find this using the formula back here. Here I would get 0 in the denominator, which would indicate to me that I have a vertical line, that the slope is undefined. Okay. When we are graphing, or I should say better yet, when we are writing the equation of a line, One of the forms that we use, and the one that I like to use the most, is called Pointslope Form. Again, back from your Algebra 1 days. So if we have the equation of a line with slope m, and it goes to the point x1, y1, we can get this from y minus y sub 1 equals m times the quantity x minus x sub 1. This comes straight from the slope formula itself. So we can use this when we're writing the equation. Now, if I'm graphing, I'd prefer slope-intercept form, but if I'm writing the equation, I prefer point-slope form. It says find the equation of a line with the given information. So in the first example, my slope is -2, and it passes through the point -2, 1. This is m. This is my x sub 1. This is my y sub 1. I substitute right into here. Notice these are subtraction signs, so when you subtract the negative, it's like adding. I'm going to have y minus y sub 1, which is 1, equals -2 times the quantity x minus x sub 1, which is a -2, so minus a -2 is +2. Now I could leave my equation just like this, or if you wanted to, you could simplify this and put y, isolate y on one side by distributing. You don't have to unless the directions tell you to. Y minus 1 equals -2x minus 4, and then add 1 to both sides would give me y equals -2x minus 3. You guys aren't familiar with this as slope-intercept form. Now let's say that we have 2 points, which of course determine a line, and I ask you to find the equation of that. Well, 2 points determine a line means that I'm going to use the slope formula, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So this would be 9 minus 3 all over 1 minus a -2, 6 over 3, which is +2. I can use either point. It doesn't matter which. I'll take this one because there are no negatives. This is a 9 here. And I'm going to write y minus 9 is equal to 2 times the quantity x minus 1. And again, I'm just going to leave it in this form. This would be good enough based on the directions. As I mentioned, we want to talk about slope because we want to talk about rates of change. The slope of a line is typically one of two things. It's either a ratio or it's a rate. Now you say, well, how do I know which one's which? Well, if the x and the y axes have the same units of measure, which typically they do, then we think of it as a ratio. And most of you guys will remember from your algebra days that they would call the slope a ratio of the change in the y over the change in the x. However, if the x and the y axis have different measures of unit, or units of measure, I should say, then the slope is considered a rate or considered a rate of change. Now, you have this more in your Algebra 2 days and even pre-calculus, where they give you different amounts and you in a story problem, and you have to come up and kind of model this after the equation of a line. Here's an example. A small business purchases a piece of equipment for $875. After 5 years, the equipment will be outdated and it will have no value. You're to write a linear equation given the value y of the equipment in terms of the time x, given that x is between 0 and 5 inclusive because of the 5 years. So there's absolutely not enough room there. I am going to kind of slide this right next to it and see if I can work this out here on the space that I have at the top of this next page of notes. Well, when x is 0 for your time here, when x is 0, the value of the machine, which is the y, is the value, is 875. When x is 5, the value of the machine is 0. So I have my two equations. Now in this case, if I was to graph with an x and a y, this would be x, this was in time, so that would be in years, and here this is y, this is its value, so this would be in money. This would be in years, this would be in money. So your rise and your run are different units, and your slope here, which is what I want, the slope here would be considered a rate. So I'm going to find the slope. This would be 0 minus 875 all over 5 minus 0. So this is negative 875 over 5, which is negative, let's see, 177 if I didn't mess up. Negative 177, is that right? 175. If I could do arithmetic, I'd be just fine. So there's my slope. All right, I already have my y-intercept. But if I go ahead and use the point-slope form, y minus 875 equals negative 175 times x minus 0. So I have y equals negative 175x plus 875. Now notice they want the value of y in terms of x, so I had to isolate the y. So I did two steps here. I distributed, of course, x minus 0 is just x, so I don't really have to think of it as distributing. And then I added 875 to both sides. Now this is a rate. This is how much my piece of machinery, whether it's a copier or whatever it might be, is losing value because of the negative, losing value each year. It loses $175 in value per year. Now it says find the value of the equipment when x is 2. Well, there's my value. So I just substitute in a 2 and do a little bit of arithmetic. This is negative 350 plus 875. So this would be 425. Now it's a story problem, so I'd like to write my answers out using proper units and also in a short sentence. So I would say the value of the equipment after 2 years, 2 years is $425. Okay, don't just circle a 425 because it's asking for the value, and the value is given in terms of money. So I mean, and even if you just slap the dollar sign on that, you're not really truly answering the question in a formal way. So that's why we typically write it out in a short sentence. You don't need a paragraph, it's just a short sentence. Now it says estimate to the nearest hundredth the time when the value of the equipment is $200. Well, this time this is the value, this is y. So I plug 200 here, I'll put it right in here, 200 in to my equation from part A. Can you still see that? Hopefully you can. And that equals negative 175x plus 875. I subtract 875 from both sides, I get negative 675 is equal to negative 175x. Divide both sides by negative 175. I do get a positive amount, so that makes sense, positive time. Now, I'm kind of running out of space here, so I'm not going to do a long division. I'm going to grab Mr. Calculator here real quick, and I'm going to quickly do 675 divided by 175, and it's about 3.857. Now, what do I round to? I round to the nearest hundredth. If you're wondering, well, what happens if they don't give me what decimal place to round to? In AP Calculus, we want to round to the thousandth unless otherwise indicated. So in this case, 3.86. Now let's answer the question. It says estimate the time when the value of the equipment is $200. 3.86 years after purchase, the equipment is worth $200. And again, short sentence, doesn't have to be a paragraph. In this case also, I wanted to make note, I mentioned this already, that the slope is an average rate of change. All right, now, because it's a line, the slope stays the same. But the average rate of change is typically thought of in terms of over a particular time interval, 95% of the time. It's over a particular time interval. So when we look for average rate of change, and we're going to be talking about average rates of change of functions and such, we want to think of this over a time interval, 99% of the time probably. A ramp rises to a height of 9 feet on a loading dock that is 33 feet long. Find the slope of the ramp. So here we go. Here we go. So we have a ramp, goes to a loading dock. Here's the loading dock. And we have a height of 9 feet. And we have 33 feet long here. It says as far as the loading dock, this is 33 feet this way. Okay, single tick mark. So this is my rise and this is my run, and I'm going kind of up to the right, drawn as far as my picture is concerned here. So the slope, this would be a ratio, because the units are the same, would be 9 feet over 33 feet, or 3/11. So that would be the slope of the ramp. So the slope of the ramp is 3/11. Now, if you go to your calculator and you punch this in on your calculator and you give me 3 decimal places, I guess that's okay, except when the answer can be written as an exact value, especially conveniently, there is no need to run to your calculator, especially when it has to do with radicals. Unless it's a story problem and you need an interpretation that makes sense, like for example, if it had to do with money, you wouldn't want to say the square root of $3, then you would definitely go to a decimal, but I try to stick with exact values wherever possible. Okay? Now, when you're graphing a linear model, as I mentioned before, my preferred manner is to use slope-intercept form. When we know slope-intercept form as y equals mx plus b, that means the slope is m. That means the y-intercept. Remember, to find the y-intercept, you plug 0 in for x, so y would be b, would be the ordered pair 0b. Now, again, this is nice, except that you can't write the equation of a vertical line in slope-intercept form because there's no slope. Now, it says here in this next part to sketch the graph of each equation. So I'm going to go ahead and I'm going to bring up an image here, and I've already got the equations written down again, so I don't have to start all over. Hopefully you can still read this. Okay, I'm going to have to zoom this in just a little bit to get a better look for you here, I think. There we go, a little bit better. And I'm going to graph this out. Y equals 3x minus 2. So my slope is 3. My y-intercept is 0, 2. Slope is 3. Y-intercept is 0, negative 2. This is in slope-intercept form. So I always start by graphing the point, which is the y-intercept at 0, negative 2. The slope, in this case, it's rise over run. 3 can be thought of as 3 over 1, positive. So from the y-intercept, from the point that's graphed, up 1, 2, 3 units, to the right 1 unit. Grab my trusty ruler. Okay. And here we go. Now, for convenience sake, I'm going to graph the other 2 equations also, lines also on this same set of axes. So that's why I label them, because this first one has to do with A. I want to make sure that I understand that this one goes with part A. Y equals negative 3 is the same as y equals 0x minus 3. So that tells me my slope is 0 and my y-intercept is 0, negative 3. Now 0, negative 3 is easy enough, but how do you do slope 0? Well, first off, I hope that you remember that if the slope is 0, that you have a line that's horizontal, but you can also think of 0 as 0 over 1. So from here, 0 up or down, 1 to the right, and then again line them up. Always found that if you could find like a plastic 6-inch ruler kind of a thing, you can not only use it as a bookmark, but then you have it handy with you anytime you have to do some graphs. And this is B. All right, the last one, I'm going to move this up just a little bit first because this is not in slope-intercept form. I'm going to rewrite it by doing some algebra. I'm going to subtract x and add 8 to both sides. Then I'm going to divide by 4, and I have negative 1/4 x plus 2. So I can see that my slope is negative 1/4, and then my y-intercept is at 0, 2. So now I can move it back. Hopefully you can still see this. Here's 0, 2. My slope is negative 1/4. Now, do you go up and to the left, or do you go down and to the right? It doesn't matter. I always think of negative 1/4. I shouldn't say I always, but usually I think of negative 1/4 as the negative being in the numerator. So I would go down 1, and then I would go right 4. Plot my second point. 2 points determine a line, a unique line. draw it out, and this is going to be C. And again, they're lines, so you should have the arrows on the ends. Now, because, as I mentioned before, vertical lines have slope that's undefined, you can't write the equation of a vertical line in slope-intercept form or point-slope form. There's no slope. So we have a third form that we like to use that's called the general form, which is ax plus by plus c equals 0, where a and b are both not equal to 0. So at least one of these is non-zero. Now, some textbooks, including I believe your Algebra 2 book, has a version of this. They don't call it the general form. They have the c on the other side, the constant on the other side. They call it standard form. But the advantage is that any equation, whether it's of a line, whether it's a vertical line or not, can be written in this form. For example, vertical lines usually just have the one single variable x in it, like x equals 5. So if you wanted x equals 5, then a would be 1, b would be 0, c would be 5. And this is a vertical line. Horizontal lines, as we did in the previous examples, just have one variable as well, but it's the variable y. And you can write this type of an equation in this form as well. You could have a equal to 0, b equal to 1, and c equal to -3. And the last example that I did in the previous, this one is pretty much in general form, except that the x is not written first, so I would rewrite this as x plus 4y equals 0. When we write general form, we usually like to have our coefficients a and b here, and then c for the constant. We like to have those to be integers, and I like to have a, if at all possible, equal to a positive number, because I just think it looks cooler that way. Parallel and perpendicular lines. Oh, you guys may remember that parallel lines from your geometry days are two lines, two coplanar lines that do not intersect. Well, if they don't intersect, that means they're slanted the same way, which means that if they're parallel, their slopes are the same. Two distinct non-vertical lines are parallel. IFF means if and only if their slopes are equal. And if or only if means that if you have two lines whose slopes are equal, then the two non-vertical lines are parallel. Of course, vertical lines are parallel to one another as well. Two non-vertical lines are perpendicular. That means that they form right angles if and only if their slopes are negative reciprocals. That's the one some people forget. Negative reciprocals. They just sometimes use reciprocal, or they just sometimes use opposite or negative. That means the slope of one line is equal to -1 divided by the slope of the other line. They're opposite reciprocals, or negative reciprocals. So if we go to write the general form of the equation of a line that passes through this point and is parallel to this line. Well, if it's parallel to this line, 3x minus 2y equals 6, I can find the slope of this line by rewriting it into slope-intercept form, because parallel means they have the same slope. So if I subtract 3x, divide by -2, I have a slope of 3/2. My slope is 3/2. My point is 3, 2. I go y minus 2 equals 3/2 times x minus 3. Notice point-slope form. Now here I really don't want the fraction in there, so before I even distribute, I'm going to get rid of the fraction by multiplying both sides by 2. I get 2y minus 4 equals 3 times the quantity x minus 3. 2y minus 4 equals 3x minus 9. Now I like the fact that my x has a positive coefficient, no fractions, so I'm going to subtract 2y and add 4 to both sides, and I get, and flip-flop the sides, I get 3x minus 2y minus 5 is equal to 0, and there, in general form, is the equation of the line that goes through that point and is parallel to that. Very similar steps below here. Notice it's the same line, right? And we notice that opposite reciprocals for perpendicular, so the slope in question now is -2/3. That's the opposite reciprocal of 3/2, because it's the same line. It's going to have the same slope. So -2/3, and the point 32 gives me y minus 2 equals -2/3 times x minus 3. I'm going to multiply both sides by 3, this time to get rid of the fraction. Distribute. Bring everything, I think, this time to the left side because I'd like my x to have a positive coefficient. It's negative right now, but if I bring it over here, add 2x to both sides. And of course, I'd have to subtract 6. And I have the equation of the line in general form that's perpendicular to this given line. So hit the problems. Make sure that you do enough practice to bring back all your fond memories of this information back from Algebra 1, Algebra 2, and pre-calculus so that you'll be ready to work on the assignment.